Welcome to Pod 4 Journal Club. Okay, so let's talk about AI. What if an AI could design not just a picture of a tool, but a tool that actually works? Well, a team from MIT and an independent researcher decided to put AI to the ultimate engineering test, designing a fully functional pair of scissors from scratch. This is what they call the scissors test, and as you're about to see, it's a way bigger challenge than you might think.
I mean, scissors seem pretty simple, right? It's just two blades and a pivot. But for an artificial intelligence, this is a surprisingly difficult puzzle. See, it's one thing for an AI to generate an image of scissors, but to actually understand the physics of how they pivot, how the blades interact, the real cause and effect of the design, that requires a completely different kind of thinking. Until now, AI has been pretty good at creating these beautiful, static, 3D models of things. Think of them like digital sculptures. They can make a perfect model of scissors, but it would be totally frozen in place. The AI just couldn't grasp the most important part, the movement. That simple little joint. That's what turns two pieces of metal into a tool that can actually cut, and for a long time, it's been a total blind spot for AI systems. And this isn't just about scissors, you guys. This gets to the real heart of modern engineering. Pretty much everything we use, from our cars to our phones, is designed using computer-aided design, or CAD. But AI-powered CAD has been stuck making static objects. It just couldn't handle moving parts. So passing the scissors test, it's not just some cool party trick, it's about unlocking AI's potential for real-world product design. So to take on this challenge, the researchers built a brand new AI system from the ground up. Its whole purpose was to create not just single objects, but complex assemblies with parts that move and interact with each other. And they gave it a pretty cool name, AADvark. This slide really lays out the huge leap forward we're talking about here. We're going from basically digital statues, these static models, to dynamic functional assemblies. AADvark doesn't just design the two blades of the scissors, it defines the relationship between them. It gets that joint that allows them to pivot and cut. That is a massive step. And the name, AADvark, is actually short for agent-aided design. And that word agent is the key concept here. We're talking about an AI agent that can reason, build, and learn on its own, all with this one goal in mind, passing the scissors test. Okay, this all sounds incredibly impressive, but how does it actually work? I mean, how in the world do you teach an AI to think like a mechanical engineer? Well, the magic behind AADvark is something called an agentic system. You can think of it like a really determined apprentice who learns on the job. So instead of being pre-trained on millions of existing designs, AADvark learns by doing. It tries to build the scissors, it looks at its own mistakes, and then it tries again, getting a little better with every single attempt. This feedback loop is really the heart of the whole system. So first, the AI writes some code to define the parts and how they connect. Then the system builds a 3D model based on that code. After that, the AI gets feedback. It sees a visual of what it made, and it gets these really technical error messages. It analyzes all that feedback, fixes its own code, and the whole cycle just starts right over again. But there was a huge roadblock. As the authors themselves point out in the paper, the large language models that power AADvark are, and I'm quoting here, imperfect spatial reasoners. In plain English, they're not naturally good at understanding 3D space. They can get really confused about how things are supposed to fit together, which you can imagine is a pretty fundamental problem when you're trying to build a machine. So to get around this, the team basically gave AADvark better tools for seeing in 3D. You could almost say they gave it super senses inside the design software. For example, they gave every single surface a unique color and texture. This let the AI identify and grab parts with way more precision. But the biggest deal was the error messages. They made them much more detailed and clear. This kind of unambiguous feedback was absolutely the key to its success. Okay, so with this new agentic system and its fancy feedback loop, did it actually work? Could AADvark really pull this off and pass the scissors test? Let's take a look at the results. The team gave AADvark its mission: 2 pictures of a pair of scissors, one open and one closed. It started with just a simple rectangular block and began that whole iterative process, trying, failing, learning, and trying again, all to match that target design. And here it is, the final result. After 20 tries, AADvark produced a fully functional CAD assembly. It didn't just look like scissors, it had 2 separate blades, handles, and, most importantly, a working revolute joint. That's the technical name for the pivot that lets them move. It had passed the test. Now get this, the entire design process, from a completely blank slate to a working model, cost less than $16 in computing power. This isn't some crazy experiment that needs a government supercomputer. It actually shows that this technology is surprisingly affordable, which could one day make this kind of advanced design accessible to a lot more people. And the whole thing took just over 4 hours. Each of those 20 design attempts took about 12 minutes, as the AI wrote code, got feedback, and tweaked its design. That is an absolutely astonishing speed for designing a functional mechanical object completely from scratch. And to prove this wasn't just a fluke, that AADvark wasn't a one-trick pony, the researchers also challenged it to design other, more complex, static objects, like a toddler bed and a chair. And it pulled those off too, proving it's a pretty flexible design tool. Now, as big a breakthrough as AADvark is, the researchers are very upfront about its current limitations and what's next. And good science always acknowledges what it can't do yet. Yeah, it's really important to remember that this is still an early prototype. Right now, AADvark can only build with simple rectangular blocks, and it only understands that one type of pivot joint. Also, the AI can sometimes get stuck in a logic loop and just needs a human to give it a little nudge to restart. But hey, even with those limitations, this is a huge achievement. By passing the scissors test, this research has brought agent-aided design one giant leap closer to being a practical, powerful tool for engineers and designers everywhere. So this leaves us with a really fascinating question. We've just seen an AI design a functional tool from the ground up. As these systems get better and move beyond simple blocks and single joints, what will they be able to create next? This research doesn't just give us an answer. It opens up a whole new world of possibilities for the future of how we make, well, everything.